Welcome to the session. Thank you everyone for coming. Wow, we have a full house. So quickly introduce myself. My name is Shirley Wang. I'm a principal product manager for Azure Data Factory from Microsoft. And today the session is about how to build modern data warehouse at scale using Azure Data Factory. Before we get started, can I see a quick show of hands? How many of you have heard of ADF or used ADF in the past? Thank you. Thanks for those hands. So hopefully for the rest of you, I'll tell you a bit more about ADF. And for those of you who have heard of ADF, maybe there's something new you can learn and take away with you. So today's agenda, I'm going to talk about the modern data engineering scenarios. And I'll talk about how you can use ADF to build code-free ETL, ELT at scale, some of the patterns and common scenarios that we've seen. And also touch upon the lift and shift scenario. And in the second 15 minutes, show you a quick demo about how to use ADF and how to get started. So let's dive in. Before I tell you about what ADF is and what you can do with Azure Data Factory, I thought I would share a few minutes on why you need ADF, why you care, right? So as all of you know, enterprise data warehouse is, people have been building enterprise data warehouses for decades. But there are some new challenges that all of us are facing. Most importantly is the rise of big data, right? All of the applications and IoT devices are generating data at unprecedented rates. And this data, we're talking about big data, is coming in all kinds of volumes and formats and different velocities. So you need really modern tools and processes to be able to handle all of this big data. How to store these at rest, how to manage these, how to do integration, how to do ETL and ELT pipelines. And the other challenge is that business requirements are getting more agile. No longer are enterprises satisfied with doing analysis of the past, right? They're trying to predict and look into the future. And they want to do this at faster scale with higher agility. So kind of, the time from raw data to insights is shrinking. And you want to be able to do all of this with the same or even reduced cost. So you need the tools to be really productive. You also need the platform to be highly cost effective. So all of this is kind of the motivation behind why we decided to embark on the journey of building Azure Data Factory. And it's been a multi-year process, and it's been a fascinating journey and to learn and engage with all of the customers to continuously innovate on this product. So we position Azure Data Factory as the full-fledged, most productive, most scalable data integration service. And by that, I mean ADF is super productive. You can use a no-code, code-free authoring and gesture to really build massive amounts of data integration processes. It is it's super scalable and serverless. So the ingestion and the transformation compute engine is available to you on demand. You do not have to calculate the peak capacity. You do not have to reserve for peak capacity. The compute can be provisioned on demand as you need it, and you only pay for the duration of the use. So it's a pure pay-as-you-go model. And it's also very flexible, meaning that you can not only use kind of the built-in mechanisms, but we also have extension points that you can plug in via custom code and via rich integration with the ecosystem. So more specifically, some of the key capabilities that are available in Azure Data Factory, you can do data movement and transformation at scale. There are more than 80 built-in connectors available at your disposal. And the ETL pipeline is super scalable, so you can ingest up to 2, even 3 gigabytes per second throughput. We've got a scalable pipeline model, so you can not only ingest data from Azure, from other clouds, but also connect with your on-prem data assets. So all of the Oracle, Netezza, Teradata, on-prem file system, SAP, you name it, we have it, right? You can really connect and embrace all of the data estate that are available within your enterprise. It has a single pane of glass for authoring and monitoring. So you have your code-free experience, but also you have your monitoring dashboard that allow you to kind of make sure that your operationalized pipeline is continuously running and to be able to debug and update as your business logic evolve. And last but not least, ADF also offers the ability for you to lift and shift your SSIS workloads, the ones that you have built over the past decade, and you do want to throw away all of that investment and you want to carry it forward. So ADF provides a fully PaaS SSIS engine runtime for you to continue to run these packages at full backward compatibility. So I'm going to talk about the two main scenarios that we see ADF being used in our customer engagements. The first one is called modern data warehouse. And by that, going from left to right, you really see this typical extraction, loading, and transformation process come to life, right? So using ADF, you can connect to your on-prem data estate, data from other clouds, from AWS or Google Cloud, and also SaaS data sources like Salesforce and Dynamics and REST endpoints. All of this data is ingested at scale and stored on Azure Data Lake Gen 2, which is a super scalable store for analytics data. And then you can prep the data, cleanse the data, and further enrich the data using either the built-in data transformation capability in ADF, or if you prefer, you can do a code-first approach and execute your own Spark code on top of Databricks or Hadoop on top of HD Insight. Finally, this data is published into the serving layer in Azure Data Warehouse, and that can be consumed by BI reporting through Power BI or your analytics dashboards. And the whole process from left to right, extraction, loading, transformation, is orchestrated, monitored end-to-end through Azure Data Factory. So you can see that ADF is really the fabric, kind of the engine under the hood to power your ETL flow. The second scenario is what we call data-driven SaaS applications. So this is typically seen when we work with ISVs who build software as a service offerings for their customers. So you'll see a very similar pattern left to right, right? There's a similar data platform in the middle. What's different is the data can be served into something like Cosmos, which is a multi-site, multi-master, multimodal NoSQL database that's super optimized for OLTP workloads. And then the data, the processed, curated assets from Cosmos DB can be served using your IoT or browser-based applications. So as a PM, I've had the privilege of working with many customers across the industry on a rich variety of scenarios, from consumer and online applications to analyze customer insights, campaign management, customer cohort analysis, customer propensity, to some of the customers in the manufacturing industry to do kind of predictive analytics, and all the way to financial and banking industry. So there's really there's no limit on where you can find ETL workloads that you need to build. So to take you through kind of the journey of how you build such a project, ETL project for a customer, I'm going to walk you through like a retail omni-channel customer who is doing trend analysis against their customer data. So their requirement is to be able to aggregate data from different silos. So you have clickstream data that's available and being collected in Amazon S3, point of sales data in on-prem SQL Server, customer data in Dynamics, and product data in SAP. So the challenge here is how you bring together all of this data from diverse assets, diverse locations into Azure and leverage the full power of the analytics capabilities to do processing, aggregation, and then get insights out of this data. So let's go through that journey. So the first step is how do you ingest this data into the lake? So like I said, ADF offers more than 85 built-in connectors. This is available to you with no additional charge. There's no basic connector or premium connector pack. All the connectors available to you at your disposal, and all you do is kind of pay as you go, right? So this is available out of the box for you. And you can very easily build these ingestion pipelines using a no-code experience, or you can drop into code using PowerShell or REST or .NET or Python SDK, whichever is the most productive approach for you. And then the ingestion pipeline is also very scalable. So you can easily scale up and down at a per ingestion step process, right? There's a concept called DIU, data integration unit. So you can say, I want 2 DIUs or I want 256 DIUs based on how much data you want to ingest. So whatever number you specify, that much compute power is available to you on demand to accomplish that step. So for the clickstream data, which is tens of terabytes, you may want to provision a bigger scale, whereas maybe point of sales data is smaller, and then you only need to start with 2 or 4 DIUs. And all of this, the throughput scales in accordance to how much compute you provision, and then you only pay for the duration of the usage. So once the data is landed into the lake, now you're ready to prep and cleanse the data and do some transformation. So we just released mapping data flow in general availability, and then also wrangling data flow is available in public preview. So what is the difference between the two? Mapping data flow is something that data engineers use to do non-schema to non-schema transformation. So it's a drag and drop, completely visual style. So it doesn't require your data engineers to learn Spark coding. And then at runtime, all this transformation logic is run on top of big data Spark cluster, so super high scale. On the other hand, wrangling data flow is something that data analysts would use for agile data preparation. So you're trying to kind of wrangle and adaptively try to find what's the best way of getting some insights out of a data set. So data cleansing, transformation, aggregation, all this built-in typical transformation logic is available out of the box, executed via Spark. And the core value prop here is you have a longer shelf life for your data integration logic. So as the underlying Spark engine evolves, this code stays valid, right, throughout the version evolution. ADF, as I mentioned, also has a tight integration with the other analytics engines. So if your preference is to write your own Spark code and run them on Databricks or using HD Insight or run store procedures, if that's your kind of favorite tool of choice for doing transformation on top of SQL DB or Azure SQL Data Warehouse, you can do that too. And the last step is loading. So for loading into SQL Data Warehouse, we've built all of the best practices through poly-based loading. You can also take advantage of all the common loading patterns, whether it's insert or upsert. And then you can also configure whether you want to truncate and kind of reload for every step, or this is an append-only operation. Once you have finished authoring the pipeline, you can now orchestrate the pipelines for operationalization in production. So ADF is also a very flexible and rich orchestrator from that perspective. So you have different types of scheduler, on-demand, scheduled, based on event. You can do for each looping, you can do if and else, branching operations. There's very rich parameterization that is available to you. So you can effectively express integration logic against large number of data sets without having to hard code hundreds or thousands of these assets. This is also something we recently released, integration with Azure Machine Learning. So not only can you do post-processing on historical data, but you also can integrate with Azure Machine Learning to score your machine learning model, to do batch scoring, etc. So all this can be chained together in a single pipeline and manage the precedent constraints. I'll flash through this very quickly so I can get to the demo portion. Best-in-class monitoring. So, you can, ADF has a built-in monitoring dashboard. So you can look at your run history. You can debug from there itself. You can step into the individual steps. You can do rerun on the select portion of the pipeline. But we also have rich integration with Azure Monitor. So you can monitor across multiple factory instances or even other Azure resources. So, alerting and all of that capability is available to you. And you don't have to start from scratch either. We've added a template library where we've made available, these are Microsoft published templates based on kind of what customers usually use. So these are the most frequently used patterns. So you can click on a pattern that best match your use case, and then all you need to do is configure the specific environment configurations instead of starting from scratch. And finally, all the insights is now available in Azure SQL DB or DW in a data warehouse, and you can point Power BI at it to do your dashboarding. Okay, so let's switch to the demo so you can really see how ADF works in action. So this is the Azure Management Portal. If you have used Azure, this should be familiar to you. It's really easy to get started with ADF. So you can go and say, create a resource. Under Analytics, you will find Azure Data Factory. And all you need to do is type in the name. Pick a location. ADF is available in the Azure Heroes and Hubs regions, and we continue to expand to more regions. There is Git integration as well, both Azure DevOps Git and GitHub. So you can check in your code and do your CI/CD continuous integration and continuous development. And then click on Create. So it's that simple. Once the factory is created, you will find it either in your list of Azure resources, or you may pin it to your dashboard. You click into it, and you can launch Author and Monitor to start the Azure Data Factory UI tool, which is where you do all of your pipeline authoring and monitoring. So I have it open right here. This is the landing page, all the shortcuts to the most commonly used tasks. And we have a rich library of videos and tutorials to help you get into the ins and outs of ADF as well. So on the left, you have a pencil for authoring and kind of a gauge sign for the monitoring. So if you click on the pencil icon, this is your kind of designer canvas, if you will. On the left is the Resource Explorer. You have your pipelines, data sets, and data flows. And here you can start to design your pipeline logic. click on the plus sign, new pipeline, and here you have all of the rich different types of activities that are available to you. For example, the copy activity is one of the most popular for ingest data, right? And you can configure source, and you have all the 85 connectors available to you right here. You can search for Oracle, all of the Oracle connectors, SAP, BW, ECC, SAP HANA, Salesforce, etc., etc. So you configure the source, configure the destination. On the settings, this is where you can specify how much compute you want to use for the ingestion step. And then that's it, simple as that. Configure the source, destination, hit deploy, and then you're good to go. So here I want to show you a pre-built pipeline. It's called Sales Analytics Pipeline. And you'll see that I have a bunch of copy activities that ingest data from Salesforce, Dynamics, S3, and so on, HTTP endpoints. And then these ingestion steps are followed by a wrangling data flow on success. And if any of these steps fail, I want to call a web endpoint that will send me like a failure email notification. And then after the wrangling, I'm going to do my rich transformation for mapping data flow. For the interest of time, I'm not going to dive into the wrangling data flow, but I do want to show you the mapping data flow. Sorry, the internet connection is a little slow here. I'm not connected to the physical line. So you'll see that the boxes with the straight line on the left are the sources, and anything with a straight line on the right-hand side are the destinations. So it flows from left to right. And on the source transform, I can do schema drift. So I can specify which are the columns I want to do transformation against versus, if I have other columns, I'm going to let them pass through. It's a straight pass through. This is a select column projection transformation. And over here, I can specify what type of partitioning scheme I want to use. Is it single partition or round robin or hash, dynamic range, key partition, right? So this is really giving you the flexibility of specifying how to do partition when you run them on the Spark cluster. When you do a join, the full set of the join semantics are available to you. When you load into SQL Data Warehouse, like I said, you can choose insert, delete, update, whether you want to recreate table or truncate table on every run. And then it's really easy to add new transformation steps in the middle. Click on the plus sign. You can do conditional split, union, lookups, derive column, et cetera, et cetera. So all of these, and we'll continue to add more as time goes on. So back to the main pipeline, I can do a debug by placing a breakpoint. So that would run the pipeline to the debug points. I can add new triggers when I want to operationalize my pipeline. So schedule trigger, tumbling window trigger, or based on event. Maybe I want to trigger the pipeline whenever a new blob is being created or deleted, so I don't have to follow a particular schedule. And once the pipeline is deployed and running in production, I can switch to my monitoring dashboard. So from here, I can see all my pipeline runs, whether they succeeded or not. I can do rich filtering through list view or Gantt view, I can do filters based on a particular pipeline that I want to look at, right? So let's say I want to look at my sales analytics pipeline that I was just showing you. I have 2 runs in the past done via manual trigger. I can drill into the individual steps within the pipeline. These are the copy activities and the execute data flow, execute wrangling flow. If I click on the eyeglass icon, I'll be able to see all the rich statistics, how much data was read, number of files, rows, throughput, including like queuing and transfer duration. So really rich statistics that are available out of the box. I can also drill into the execute data flow. And here you'll be able to see the individual steps, including all the transformation steps that I had executed, how many rows were processed, rows and columns, and partition information if partition was used. So here I'm using a live factory, but I can easily switch to Azure DevOps, Git, or GitHub integration. I can also, as I showed you from the slide, using built-in pipelines, or I can publish my pipeline as a template and share it with other engineers within my organization. So you have the best of both worlds, right? Both Microsoft published templates as well as the templates that your coworkers have developed. Right, so again, if you have existing SSIS packages that you want to take advantage of, and to be able to run these with compatibility, higher scale in the cloud using the elastic compute that is available to you, ADF offers a fully managed PaaS service to run the SSIS packages with minimal to no modification. And all the integrations that you're familiar with on-premise, maybe you have third-party plugins that you had taking advantage of through Theobald or SentryOne, Cozy Rock. All those third-party extensions are still available to you, so there's really no loss in functionality, and you really gain the scalability and performance that Azure Cloud has to offer. So in conclusion, hopefully I've conveyed at a very high level that Azure Data Factory is the most productive and trusted hybrid data integration service. You can use it to build the full spectrum of ETL and ELT workloads and really run your data integration logic at scale in Azure. And hopefully you will be able to take the knowledge that you gained today and go back and get started. Get yourself familiar with Azure Data Factory and build the most productive ETL logic with your customers. Thank you.